The cybersecurity landscape of 2026 is defined by machine-driven operations executing at a scale that eclipses human intervention. Autonomous threat actors now plan and execute complex, multi-step campaigns without a human in the loop. The barrier to entry has dropped. Hackers now focus on orchestrating AI-powered tools at scale, effectively industrializing the cybercrime ecosystem. Most enterprise leaders believe their modern security architectures are prepared for this. They rely on standard identity and access management and zero-trust frameworks to secure the perimeter. There is a specific technical gap in this defense. Current identity models were built to verify human users and stable, long-lived service accounts. Standard authentication logs often remain empty because autonomous agents operate too quickly for legacy systems to capture a meaningful audit trail. Securing the 2026 enterprise requires us to rethink how a network defines identity and move past our current defensive assumptions. To understand the vulnerability, we need to distinguish between traditional large language models and agentic AI systems. An LLM responds to a prompt, but agentic AI connects to model context protocol servers to execute operations. They use broad, static API keys, bypassing multi-factor checkpoints. Agents rapidly spawn sub-agents for network operations, then vanish, leaving no trace in legacy logs. This creates the automated-to-automated, or A2A, workflow, where one autonomous agent interacts directly with another. The operational danger here is implicit trust. In an A2A loop, agents are programmed to accept one another's outputs as valid by default, removing human oversight from the chain. Trend Micro highlights a scenario where an automated inventory management agent hallucinates a severe stock shortage. Because the workflow is fully automated, hallucinated data is passed immediately to an automated procurement agent. The procurement agent then executes a massive emergency order, creating immediate financial and logistical damage before a human even notices the error. Unchecked AI autonomy creates self-reinforcing loops where hallucinations become operational events, bypassing all human verification. The risk extends beyond operational data and deep into the actual software supply chain. Developers are increasingly adopting vibe coding, using LLMs and integrated development environments to rapidly prototype and deploy applications. Between January and September 2025, vibe-coded apps on Vercel grew by 57%, while Lovable saw a 660% increase. This speed introduces vulnerabilities. Research indicates vibe coding produces unsecure code 45% of the time, injecting flaws directly into production environments. One of the most insidious threats from this practice is the creation of hallucinated dependencies. When an LLM invents a fake software library, attackers use slop squatting to weaponize that hallucination. The attacker registers the fake library name in a real open-source repository and uploads malicious code. When the AI hallucinates that library again, it pulls the poisoned package into the production environment. Since the AI handles dependency retrieval, the human developer has no reason to suspect a vulnerability. The drive for faster software delivery is inadvertently building automated backdoors into the global supply chain. State-sponsored advanced persistent threats are now leveraging these interconnected vulnerabilities. These groups have moved toward a collaborative premier pass-as-a-service model to maximize their efficiency. In this system, one group focuses exclusively on breaching the edge and maintaining a persistent foothold. After breaching the perimeter, they hand off access to a specialized second group to execute the espionage or ransomware phase. Inside the network, these actors use AI to live off the land. AI-powered malware generates context-specific commands using native host tools. This behavior mirrors legitimate administrator activity, allowing it to evade traditional endpoint detection and response scanners. Because the commands look like standard maintenance, they are often invisible to security teams. We saw this in the S1 Singularity case, where attackers weaponized AI command line tools like Claude and Gemini for internal reconnaissance. APTs are also targeting automation scripts within CI/CD pipelines to harvest sensitive production secrets and cloud credentials. The most complex threat involves the evolution of the state-sponsored insider. State-sponsored actors are using forged identities and deepfake-assisted interviews to infiltrate IT vendors. These operatives are hired as legitimate employees, which gives them privileged access and allows them to bypass the external perimeter entirely. Modern APT operations prioritize collaborative, stealthy supply chain infiltrations, moving beyond the obvious signals of direct brute force intrusions. The 2026 landscape is defined by the capacity to automate disruption with unprecedented speed and efficiency. Organizations must shift from reactive, signature-based defenses toward a model of anticipatory resilience. This starts with a redesign of identity and access management. AI agents must be treated as accountable identities. This requires continuous authentication and behavioral analytics over static API keys. To counter runaway automated loops, critical processes must mandate out-of-band verification. Machine-speed transactions must wait for secondary, external human approval. Enterprises should also implement strict policies to reject and sandbox any non-pre-approved AI models. All vibe-coded software must undergo rigorous, automated red teaming to identify vulnerabilities before it reaches a production environment. Further ahead, the risk of harvest now, decrypt later attacks makes immediate migration to post-quantum cryptography essential to protect sensitive data long-term. AI has moved beyond simply augmenting threats. It has fully industrialized them. In 2026, the advantage belongs to those who can secure the intersection of human oversight and machine-speed execution.